Hello everybody, sorry I had a little hiccup there. We are going to do the creeping on Quora thing today because, yeah, there's a lot of questions on Quora and we're not going to get into motivate. There are good sides of it. There are legitimate questions and stuff like that, but there's a lot of trolling, there's a lot of dishonesty, there's a lot of stuff that just, I don't know how to describe it. But anyway, we're going to go through a few geology questions as they come up. The music you hear in the background is by White Bat Audio. It is a royalty copyright free thing. So yeah, I don't want any BS about that. I just want to give you guys a little bit of music to listen to while I ramble. We'll keep this relatively short, I think. And all right, so let's get into these a little bit. If Earth is perfectly round, I assume that means spherical, then how is it possible that there are 7 gigantic plates on its surface? For reference, try to stick flat plates on a spherical Earth model globe. The plates and plate tectonics are not the plates in your cabinet. It's a term we use. It has a different meaning than what's in your cabinet. Now, I don't know if this is coming from a place of honesty or not. It could be, but I don't think that's what they meant. I mean, yeah, if I try to deform a plate onto a round surface, a flat plate onto a round surface, I'm going to have to crack and break it and make more plates. Tiberius! Oh, Tiberius and Huck are being adorable. I'm going to get some of this right here. Anyway, but plates formed long after the Earth did. The plates have curvature to them, just like the Earth does. Okay, there's nothing ominous about this. Matter of fact, they move about the globe according to Euler poles. You know, the Earth turns on its axis. You know, North and South Pole, these individual plates do that too, and they don't align with north, true north. There's models I could show you, but we're not going to get into that. So they're not flat to begin with, okay? Plate tectonics didn't start at the beginning of Earth. Most of us are pretty confident of that now. Those of us that study that, some of the old timers still hang on to it, but they can't model it right. They just try to keep extrapolating into the past, and then they don't get what we observe in the rock record. But you know, scientists are humans too, and we can be a little bit stubborn when it comes to letting go of our favorite hypotheses or theories. So anyway, I hope that answered that. I'm going to try to keep these as short as possible. I don't even know how many I'm going to answer. Why is the area of Earth's oceans larger during the Columbia supercontinent? The reason for the area of the continents or oceans to decrease in size. We actually don't know if that's true. That's a good question. I'm not going to lie. That's a good question. But we don't know if that's true. Columbia was supercontinent. It's actually the one I work with the most. It's also known as Nuna. I like using Nuna. I think it's cooler sounding. But it's the same thing. Rodinia came after that. Some people are familiar with Rodinia at the very end of the Precambrian. And of course, during the Phanerozoic, about the middle of it, we have Pangea, and everyone's familiar with that. But Columbia is circa 1.5 billion, 1.6 billion years ago. And the continental masses today, if we pull all those out and reassemble it, are less surface area-wise than they are now. Does that mean there was less continental landmass? Could be. It probably actually is. But we need to be careful. A lot of that stuff has been compressed due to orogenic events, mountain building events. And then, the mountains get eroded, but that crust is still deformed and compressed, sometimes by dozens of kilometers, if not more. Earth isn't getting any bigger, so when you collide continent upon continent or ocean upon continent, the ocean goes under, you're going to get mountains, and that compresses the continent a little bit. However, that probably doesn't compensate for it. So what else could it possibly be? Well, it could just be that, continents were smaller. That could be a real good thing. I mean, that's a possibility. As we know, and like I said, plate tectonics was not in operation 4.5 billion years ago. And it probably wasn't until significantly later in the Archean, at least, if not later. I fall into the beginning of the Proterozoic camp. There's some people even think it started later than that. But anyway, or it started inside. Anyway, that's not the point. The point is that when the Earth first cooled the crust, it probably had very little felsic parts to it. Granitic stuff that would form continents as we think of them today. Deep ocean floor, continents above land. That probably wasn't a thing. So they had to grow somehow. And that's why we don't think plate tectonics was in action. So they did grow originally. They're definitely, at the beginning of the formation of the Earth, or not even 500 million years later, there was definitely less continental mass. But when did it get to modern levels? I don't know. And you got to remember, too, a lot of what's accreted to the continents are actually island arcs. So they started out as ocean, from the ocean crust. So even though most of the continents are felsic or granitoid in nature, just sticking with the igneous, I'm being very generic. I know we have sedimentary rocks, but actually the crust as a whole is the sedimentary rocks are the least numerous. From our standpoint, walking around, we think they're the most abundant, and covering the continental surface they are, but for the crust as a whole, they're the least common. It's metamorphic and igneous, and metamorphic derived from igneous. So they have grown, at least to a degree, and through accretionary terrains. Well, a lot of these accretionary terrains, like I said, were island arcs, but some were microcontinents. Where did they come from? And these microcontinents seem to have, popped up in the Archean. We don't have any confirmed Hadean parent, primary, if you will, cratonic rocks that are Hadean, so 4 billion years or older. We have some dates from that time, but those are in question. Then they probably will be for a while. Now, the only ones that aren't are the Jack Hills. You might think those are over 4 billion, but those are detrital zircons. Those are not an igneous rock. They are in metasedimentary rock, which is far younger. But anyway, so here they have, Columbia, but that probably didn't exist this far back. And, but we'll just leave that there. But this guy that answered it is also microbiology. I'm a professional geologist who studies Precambrian. Take it as you will. How does Earth have water if it's made up of rock and metals? Yeah, so not everything's concentrated in the same place. The Earth, we question, it depends on what you mean by more. If you mean sheer number of individual atoms, it's a toss-up between if iron is the most abundant element in Earth or oxygen. Well, what is oxygen tied to? A lot of places on the surface. Hydrogen, which makes water. So in our early atmosphere, we probably had a lot of hydrogen. And we obviously had a lot of oxygen. And what didn't escape into space probably got condensed into water. Now, I know a lot of people sit there and say water came from comets, but it's funny how we come up with these ideas and then we start to, move away from them. But anyway, talk for another time. Can the Earth's inner core be made out of a black hole? No. Next. Is there any evidence of evolution within the geologic record? I don't know if this question is coming from a honest place, but I doubt it. So let's just answer it. Now, it depends on what you mean geologic. Is there any evidence within the geologic record? Yeah, fossils. Plain as day. Fossils, geologic time, the layering of rock units relative to one another, and absolute dating. We know the fossil record shows a change of life over time, organisms over time, as evolution would predict, as evolution would show. We don't find rabbits in the Cambrian. We don't find things like that. We don't even find mammals in the Cambrian. Matter of fact, we don't even find any land anything in the Cambrian. Okay? So as you go through the geologic record, life reflects what we'd expect from evolution. But even if we didn't have a single fossil, we could deduce evolution happened because we have things like DNA. Talks for other times. Okay. I don't give a rat's ass about that. Do rocks also contain atoms? Now, questions from ignorance, I don't say are stupid. Because if somebody doesn't know, it's not their fault. Yeah. So yes. But like stuff like this, yes, and so does your head contain them. That's kind of snarky, and I don't know John Knight. I don't know his education. I don't know if he's a real person or if he's just trolling or what. So this question I would answer honestly: Do rocks also contain atoms? Yes, every bit of matter that you come in contact with is made of atoms, whether it's solid, liquid, gas. We're not going to talk about plasma. What would happen if a huge miles-wide hole that went deeper than Earth's crust were to open up on the planet? So somebody wants to know if a big rift formed all the way down to the mantle. Well, we'd have bigger problems, but as the Earth would probably be fine. It just doesn't. I mean, that's a hypothetical that really, I don't know. What do you mean by mantle? You mean lithosphere or do you mean asthenosphere? I don't know. So, anyway, the mantle isn't just the mantle. It's different in different places. When did the dinosaurs live? Was there plate tectonic movement during the time? Dinosaurs lived during the Mesozoic, about 250 million. I think they evolved in the Triassic, though, so a little later than that, to 66 million years ago when Chicxulub occurred. A meteor hit asteroid. So, and was plate tectonic movement during that? Was there plate? Yeah. Pangea was still breaking up during that time. So it began to break up and kept doing it. How does the temperature of the Earth's core not burn through the rest of the Earth and cause it to be a huge fireball? Because that is under pressure. And due to its mineralogy and its composition. If we were on a big ball of hydrogen and the center of the Earth were that hot, nothing would probably happen either. But, it's because this actually is turning out to a bunch of rock between. That's essentially the answer. The rocks that insulate us from that as you get further from the core. Now, obviously, you do get lava erupting on the surface, but a huge fireball, I'm not sure what that's even supposed to mean. But if you just mean the surface of the Earth, not lava, well, yeah, bunch of rocks between us. What are some good beginner rocks to facet? I'm not going to touch that one. How many cubic miles of rock are there on Earth's surface? Cubic miles of rock? Well, that would just be the cubic miles of any. That's just, I would just take the surface area of the planet. Because remember, the oceans have rock at the bottom of them too. But that rock has rock under it and so forth. So I don't know where you put the line. So I would just do the surface. What is the area of Earth's surface in miles? Area of Earth in miles. I cannot type today. Okay, there's your answer. Next. Oh, is it going to Yeah, I did. Okay, then we'll take this one. This one doesn't sound like trolling. But this first sentence is correct. Well, if the oceans are lost to space, it won't be a water world. So that's true. And it won't get hot enough to melt either. That is also true. What's going to happen, the order of events, is macro life's going to go extinct in a little over 500 million years, 600 million maybe. The oceans, plate tectonics, we've had oceans and no plate tectonics. So plate tectonics does not mean you have oceans. Oceans do not mean there's plate tectonics. Those are not correlative things. So even plate tectonics will stop about 1 billion years in the future. Oceans, probably around before that a little bit, maybe a little after, I don't know. I think something like that. And once the oceans are gone, we still have some groundwater and stuff, and microbes will continue. But the sun is eventually going to get so big and hot when it runs out of fuel, or just not even running out of fuel. So, the Earth itself will be around until the sun starts going into its red giant phase. Life on Earth will not be around that long. Life on Earth as an overall thing probably has a little over 1 billion years, and that means single cell. Like I said, macro life, probably about 600 million. And that's really what people want to know. As for the oceans, a little over 1 billion. Why does it I hate that. I want to turn that off. I don't give a shit about what politicians do and what. We already answered this by a difference. Okay, so this is a trolling question. We already saw that one. Where did the rocks that caused the Big Bang come from? The Big Bang is the beginning of the universe and everything in it. Well, at least this universe, as we know it. We think. So that question doesn't make any sense. However, some parts of Earth, essentially flat. I get what he means by that. I don't mean flat as in tabletop flat. He means from a human perspective. And others are mountainous. That has to do with plate tectonics. Pure and simple, tectonics. If we didn't have or plate tectonics in our case, but you can have other forms of tectonics like lid tectonics. But that aside, if we had no tectonics on this planet, the continents would have been eroded to the ocean to sea level a long time ago. How and why is Asia finally become 10% brighter because the Earth is its oceans? Stop at this point. These are not correlative things. These may not even happen at the same time, and I kind of talked about that. And the Earth will lose its oceans when the surface of the planet, the energy coming from the sun, becomes too hot to maintain oceans. Is that 1 billion years? Yeah, maybe. Maybe 1.2 billion. Maybe 1.5. Depends. As soon as our even solar models are correct. And why will plate tectonics stop at this point? Nobody's saying they're going to stop at the same point, not even within 500 million years of one another. Plate tectonics has about 1 billion years left in it. Maybe a little less, maybe a little more. It also depends on other factors. Like, our understanding of plate tectonics is basically based off modern observations. There are some people that think the plates stopped moving in the past and then started up again. I don't buy that. We seem to have more evidence of continuous moving plates. Just because a supercontinent formed doesn't mean ocean plates weren't still moving. Anyway. Ocean floor impacted significantly, but is the pressure near the ocean floor tectonic? Yeah, same as the rest of the planet is. What triggers an explosion on Earth, such as volcanoes and meteorites hitting? Number one, volcanoes can be explosive from our point of view, but it's not like the Earth explodes. Earth's too big in relative size. It's not even analogous to popping a tiny pit bull on you. I mean, do you consider that an explosion? At the little one? Or a blackhead even? But anyway, it's perspective. Meteorites hitting the Earth's surface have to do with where bodies in space are and if their orbits cross Earth or not. It doesn't really have anything to do with anything much else. Volcanoes form for different reasons, but you don't need a volcano to have magmatic activity. In a nutshell, basically, lava comes from magma in the earth, the rock that melts becomes non-rock because you have to be a solid to be a rock, and it moves to the surface and cools into rock, minerals and rock. Now that happens for different reasons. In spreading centers, you get a thin crust, and if you look at the melting temperatures of a lot of minerals and rocks even, or just pure metals, they're a lot higher than rock actually melts on Earth, because that's in standard temperature and pressure. Well, the Earth itself is under pressure. Everything on the ground is under pressure. So a lot of times, just removing that pressure, like in a spreading center, will cause the rock underneath to melt and hence erupt. So, most spreading centers on Earth are probably shallow origins. Another way to get it is add water. That lowers melting temperature, like in a subduction zone. You get say this is a continent, and you get or even another ocean, it doesn't matter. This is an ocean plate going under. And that bring water down, and it'll cause melting right here. And a lot of the water will come back up to the surface too, if not most of it. I think all of it actually probably does. But anyway, I digress. And that'll melt the rock too, and then it'll rise to the surface because magma or melt is less buoyant than the Earth is. No, we already did that one, I think. Okay, I think we're going to stop it here. Let me know what you guys think of this. I can always do this another time if you enjoyed it. Anyway, leave any questions or comments below, and I hope you learned something.